I hope my screen is visible. Maybe someone can confirm in the chat.
Yes, sir.
Yeah, sure. Also, you don't have to call sir or anything. You can just call me Aveen. So that's totally fine. Okay. So like I said, we have some problem-solving questions. So let's get started with the first question. So the pattern is very informal. You don't have to you can just answer these questions and just post your answers in the chat. So the first question is very simple. So you must have covered about representing an image in different formats the first session. Yeah, I think someone has a question. Okay, there's no question. Sorry. So yeah, the first question of today's is how do you where are the different formats that you can represent? So what are the different valid imaging color formats which you think is valid out of all these? So there are multiple correct options. So maybe you can just take a minute or two. Let's just wait for a minute. Yeah, I think pretty much there are a lot of answers. A lot of people are talking about A, B, C. Yeah, RBX is invalid. Okay. So the correct answers are A, B, C, D. So, as someone already posted, there's only one invalid representation, which is the RBX. The remaining all have a representation, which is a valid representation. So, I'll just briefly discuss each one. So, first one, RGB, that's a very standard representation. That is what we all see in the normal images, digital images, which is red, green, blue. The second one is the RGBA. So, RGBA, the same RGB stands for the red, green, blue, whereas A stands for alpha. So this is more used when you're creating apps, right? For example, if you create an app and you have a button on top of another button, or you want to have that button with less transparency, you see such type of apps nowadays a lot, where you have multiple layers, where one layer is a little bit transparent than the other. That transparency is how much that particular layer should be transparent or not. That is what alpha represents. So this is a very new age, I would say, RGBA representation. Then there is also something called as CMYK, which is cyan, magenta, yellow, and black or key. So this is a very popular coloring format used in printing processes. So an obvious question might arise: why don't you use the same RGB for the same printing process? But what happens is the RGB is a emitting light format, whereas printing you don't emit anything. Instead, you absorb the light. So there is a difference when you want to emit the light, which format you want to use, and there's a different format when you want to absorb that light, and then the whichever person is looking at it, he'll look at the color in a different way. So I would definitely suggest reading more about this process of subtractive color and additive color models. You'll understand why CMYK is helpful instead of RGB. And then the last format is hexadecimal. Hexadecimal is basically a type of representations which is in the hexadecimal code. Like 0 to 9 is the decimal code, which we all know. Hexadecimal is goes from 0 to 15. Total 16 values will be there. So that is how the representation which we will be using to represent a particular color will be done in hexadecimal code, hence the format hexadecimal. Okay, there are a couple of questions. The first question is, please share the PPTs. Yeah, I'll be sharing all the PPTs, the collab notebooks, which I'll use for today's presentation. I'll be sharing it in a Google Drive, and the link will be shared with you from the NPTEL office. The second is, could you give a brief about sRGB and sorry, can you? I'm not sure about the sRGB and LAB. Maybe can you type in the full form of it, Kranti? Or maybe you can unmute and let me know about it. Where did you encounter such type of colors?
So actually, I'm also not aware of that. This is one of the question in the assignment zero. Which color space models perceptual uniformity more closer to human vision? So the
Okay.
examples are RGB, CMYK, sRGB, and LAB. Yeah,
Uh, I haven't come across sRGB. Sure, I'll also read about it and get back to you in the next session.
it's in a basic assignment zero. Yeah.
Sure, sure. One other question, like usually you'll be getting your assignments released before these sessions sometimes. So we are strictly instructed by the NPTEL office also not to discuss the current assignment questions. So
No, it's
no,
not
no,
a weightage one. It's a basic one to check
yeah,
the
I
basic.
get that. Yeah, not for this one. I'm just talking and going ahead in the future. So try to refrain from asking from the current ones so that it will be common for everyone. Okay. So going to the next question. So this is a little bit of involves a pen and paper. So assume that you have a 2n cross 2m image I, and you have a patch operator that computes the average of p cross p image patch of an image. Further, assume that the minimum of n comma n is greater than or equal to p, which is greater than or equal to 1. How many different patch operations does value of the cells n comma n contribute to? So these are the different options. You have one correct option. So if I'll just wait for a minute or two, maybe you can just calculate it and let me know the answer. Sorry, what do you mean by first section? Nisana, can you just elaborate on that? No, NM is not the right answer, Manoj. NMP is also not the right answer. Okay. Yes. So Nisana, this is the first class. So basically, maybe I think you missed the introduction. So basically, we are three PMRF students who will be conducting live sessions. The three sessions will be at three different times in a week. One is on Saturday, one is on Sunday, I believe, and one is the Tuesday class. So all the three of them will be having the same content for every week, so that people who miss the other classes can attend this particular class. Okay, I think Purna Chandra, like if you have a question, you can unmute and ask. Thank you. Purna Chandra, I think you're not audible. Maybe you can enter your question in the chat. Um, Manoj, can you unmute?
Yes, sir. Sir, actually, when we are doing the sessions, sir, already representing some PPT. So can we get those PPT for the reference?
Oh, so those PPTs are already available in the NPTEL website in the course content out, right? You on the left side of the there'll be a sidebar. On that there'll be lecture slides for after every week. You can click on it and there'll be a Google Drive link where you can access that.
Yes, sir. Okay.
Hello.
Thank you.
Yeah. Okay. Yeah.
Hello.
Purna Chandra. Yeah, Purna Chandra, please go in.
Yes, 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 yes. The last previous tutorials, their recorded sessions are not been updated. Like that
Okay.
it has not been shared. So when we even after raising a lot of questions on the consortium, that is the forum, no reply from any of people. So what is when we are going to get?
Sure, sure. I'll do one thing. I'll immediately see what the issue is and I'll share. So you basically will get an Excel sheet link where you'll have different PMRF live
No
session
Excel sheet
tutorials.
also.
Yeah,
But
I think I'll just
I
confirm.
request you also to immediately after the session, like within tomorrow morning, if you upload it, so then it will be great.
Sure, sure, sure. Sure, sure. I'll just
It helps in solving our assignments.
yes, sure. I'll do that right away. Don't worry.
Sir,
We'll be getting the list.
also, sir, we are also having YouTube, I mean, link also. So I'm also referring that one. So it is fine, no? Like, managing that one.
So YouTube link you're referring for today's session or for
No, no, for the, I mean, sir is already having recorded almost 79, 78, almost whole lectures in the YouTube also, that NPTEL channel of the YouTube.
Oh yeah, yeah. So that is last year's content which you're talking about. So the problem will happen is the last year content is changed from this year's content. So this year the content we have increased a lot more new concepts. So you can refer to the last year's videos for your knowledge, but the content is a bit different this year.
Okay, okay, sure, sir. Okay,
Sure.
thank you, sir.
Yeah. Is there a question, Ayappa?
Sir, is it audible, sir?
Yes, yes, you're audible.
Sir, now I'm doing the PhD, sir,
Okay.
on hyperspectral unmixing, sir.
Just a minute. Like, if you have any personal questions which are not related to the course or this particular tutorial, we can discuss at the end of the session. Not a problem.
At the end of the session, sir.
Yeah, because everyone is attending for this particular course and tutorial. So let's discuss after at the end of the session.
Okay, okay, sir. Thank you.
Okay, I think there's a question. Can you clarify one more time? There'll be yes. So basically, normal NPTEL which professor conducts, right? That lectures will be uploaded on the NPTEL website. Apart from that, there will be live sessions which will be conducted by three PMRF students. one is conducted during this time slot, which is Tuesday 7 to 9. There are two other sessions conducted by two other PMRF students on Saturday and Sunday, I believe. So we have make sure that all these three live sessions, which will be conducted on Saturday, Sunday, and Tuesday, they all will have the same content, so that people who missed joining on Saturday or Sunday or Tuesday can join in other sessions, basically. So all of these three will be having a recorded of the same tutorial like I'm recording for today's session. We'll be uploading it on YouTube, and will also be shared with the PPT which we create along with the collab box. Is that clear, Manoj?
Okay.
Yes, sir. Yes, sir. Thanks for the clarification. Thank you, sir.
Sure, sure. Okay, then. Yeah, let's get started with today's session. Like, if you have any other questions about some logistics, let's just keep it at the end of the session because we have a time limit for this. Okay, so I think you had time for this. So the answer is D, which is P square. So what you can see is basically what we said, that the patch operator can basically be at any position, but there's a one specific condition, that the patch operator P should be greater than the minimum of n comma n, and also it should be greater than 1. And the only condition is the second point, which is the most important condition, that in that entire P cross P patch, the top left corner of the patch should be in such a way that the bottom right corner of the patch includes the n comma n. So if you normally take any example, input nm as different values, and look at this pattern, you'll observe that this is the most important criteria, that the top left corner should be in such a way that the bottom right corner will always include n comma n. So what are the different conditions for the I and j value to be? So I should be basically greater than n minus p plus 1, and it should be less than n. I is the top left corner pixel value of that patch P cross P. And j also should have a similar condition, that it should be greater than m minus p plus 1, and it should be less than m. So what are the different possible values for I? There are p values because it is going from n minus p plus 1 to n. Similarly for j, there are p possible values. So what are the total possible values that are that will satisfy these conditions? P cross p, which is p square values, which is the option D. So I hope this is clear. I'll just pause for a quick second. If you have any questions, just let me know. Okay. So moving on. So question 3, it's again a very simple question. It doesn't require a lot of solving. It's mostly logical. So let's assume there are two matrices: A matrix, which has the dimension 2n comma 2n, B matrix, which has the dimension 2p comma 2p. And these are the conditions, that n should be greater than or equal to 2p, greater than or equal to 2. So another further condition we impose is that A is a skew symmetric matrix. I hope you all are familiar with skew symmetric and symmetric. And then B is a symmetric matrix. And now we are saying that let C be another matrix, which is the output of the operation B convolution of A. Then the question is, what is the sum of all the elements of C? So these are the different options. There's only one correct option. So if just take your time and drop your answers in the chat. So the major logic just lies in what the skew symmetric matrix and symmetric matrix properties are. If you understand that, the question is very simple to solve. Okay, I see some answers. Events at C. Okay. There's no option F, Nisana. Do you mean? Oh, I don't know what option you mean. C, right? Okay. Any other options other than C? I think everyone got it. So yeah, answer is C. So for people who didn't get it, so the simple explanation is, what is a skew symmetric matrix? It means that A transpose is equal to minus A. That is the property of a skew symmetric matrix. So if A transpose is equal to minus A, then it means that each element in that Aij will be equal to minus of Agi. That is how this entire sum of all the elements of A becomes 0, because of this property of A transpose is equal to minus A. Because as you also know, skew symmetric matrix, the diagonal elements will also be all 0. Now coming to B is a symmetric matrix, which means A transpose is equal to A. Now what does convolution operation means? It means nothing but you are moving B on top of A, and convolution is just involves multiplication element wise and summation. Since all the sum of elements of A is 0, any weighted sum will also become 0. So that is a very simple property. So things to remember is A transpose A is equal to minus A makes all the sum of elements of A to 0. And then convolution is nothing but just a element wise addition and multiplication. So you take the weighted sum of any sum of elements of A which results in 0. This weighted sum will also result in 0. Okay. Since most of the people got it, I'll quickly move to the next question. If you have any questions, you can always post it in the chat. Okay. Coming to question 4, this particular kernel which you see on the screen, K, this 3 by 3 kernel 1 0 minus 1, do you think this kernel is separable or not? If you think it is separable, what are its singular values? But even if it's not separable, what do you think is the singular values of such a kernel? So I believe that you all have gone through the lectures, week 1 lectures. So separable means it can be represented as product of two simple vectors. This is a matrix, right? If you can represent it as a product of simple two vectors like U into V transpose, then it means that this kernel is separable. So I'll just quickly pause and you can let me know your answers. I'll maybe give you a hint. So separability can be related to SVD, singular value decomposition. So just think of it in those lines. What does SVD represent, and how can you connect singular value decomposition with this particular kernel? Okay, maybe I'll let you give you the answer. So the first answer is no. This particular kernel is not a separable kernel because and also the singular values are three values. So why it is not a separable kernel? Because the sigma, right, which is the singular values, it is more than one. So a kernel can only become separable when the number of singular values are one. Why? Because if number of singular values are one, then in this summation there will only be one non-zero element and all the other elements will be zero. And then you can easily represent this K as a product of U into V transpose. So that is why we call a particular kernel as separable if it has only one non-zero singular value and rest all singular values are zero. So you can also how do you find singular values? You can think singular values to be nothing but the rank of a matrix, which is nothing but the number of independent columns in a matrix. So I hope you all are familiar with that. If there are any questions related to that, maybe you can take it at the end of the session because that is most of the prerequisite for this course. So yeah, so again, reiterating my answer. So the kernel is not separable because the number of singular values are more than non-zero singular values are more than one. Okay, moving on. So this is the fifth question. So can you compute the convolution of these two sequences? Both of them are 1D sequences, as you can see, A and B. So also please use padding for this. So can they'll after using padding, what is the value of the convolution of these two sequences A and B? You can just post your answer in the chat. I'll just wait. Maybe I'll give you a hint for this too. Remember that a convolution is nothing but element-wise multiplication and summation between a kernel and the input sequence. In this case, you can treat A to be the kernel and B to be the input sequence. Kranti, no, your answer is not correct. Remember, Kranti, use padding. I mentioned it in the question. So kernel, treat your A matrix to be the kernel, B to be the input sequence. So padding is not necessarily with 1. Mitanshi answer a question. I don't think your values are also correct, Mitanshi. So maybe just we'll give it another 30 seconds to 1 minute. Let others also try. Um, no, I don't think. I think Ivan's answer. You're almost right in the first few values, but it's not completely correct, Ivan. You know your answer is not correct. Okay, I think we can discuss it. So this is the right answer. The answer is 1 minus 1 minus 1 3 6 minus 2 minus 6. So first important thing which you need to remember is in convolution we first flip the kernel. So remember that what was the actual kernel you had? 1 0 minus 1. So after you flip the kernel it will become minus 1 0 1. And then since I said padding is allowed, you need to add two padding zeros at the front and at the end of B. And then nothing else. Then start from what is it, just placing each of this minus 1 0 1 to the input B padded with two zeros, and you just do element wise multiplication and summation. So then you'll get this particular answer, which is 1 minus 1 3 6 minus 2 minus 6. I uh, I hope this is clear. If you have any questions, I'll just quickly why two zeros need to be padded. Yes, so because the kernel over here is total 3 values, right? So the reason we are padding with padding is so that the kernel, the first value of the kernel, the entire kernel will be able to coincide with the input sequence B. So in that case, if you're just padding 1, there'll be one more element of A which is not being multiplied with anything, because you need to place that kernel at the correct, the 1 should be placed exactly at the B's first value without padding. So that is why you need to pad with two zeros. It depends actually on the kernel length. If I had just two values in the kernel, then only one padding will be done. I think there's a question, why two zeros padded in B, not in A? So here we are padding the input sequence. Like I said, consider the kernel to be A. You never pad a kernel, you always pad a input sequence. Kernels you don't pad. So that is why we're padding in A and not in B. We're padding in B, not in A, sorry. And we need to pad it in the end also, because you need to let the last element of A be combined with the last element, or the first element of A with the last element of B. So I would suggest maybe just look into how the convolution operation actually happens with respect to the any signal processing uh, book you take, or for example, you just search also the signal processing convolution operation between 1D sequences, one-dimensional sequences. You'll understand better where the zeros are padded. So there is actually a formula which will tell you how many zeros should be padded and all. So I didn't go because that will be deviating from the class. So maybe you can always take a look at that. And if you still don't understand, maybe we can discuss it in the next class. So there is definitely a reason why two zeros are added in the start and in the end. And that comes from actually what should be the length of the output, which depends on the size of A and B. So there's a bit of a theory which will be a deviation for this course. I think there's a question. Sir, any YouTube class for us? What do you mean by YouTube class? Can you please elaborate? Maybe you can unmute Nisana and can you please explain what do you mean YouTube class? Okay, I think we can move ahead. Any other further questions or anything? Okay.
Can I ask a question?
Yes, please go ahead.
It's audible?
Yeah, you're audible. Can't see your
Yeah,
name. One second.
yeah. Myself Satish.
Yes, yes, please go ahead.
Adding just now it's explained.
Mm,
I remember in the class also it's explained from the image point of view that no whatever the kernel length is there, when we like here the 2k whatever the k value, so when you multiply it you lost the information in the border. So to avoid that loss of information you are padding, am I right?
From an image perspective, yes, but in this case, we don't have particularly any image. You can think of this to be any signal, but the reason is still the same. We are not
Same only.
same. It's all padding is usually used so that you don't want to lose any information.
Yeah.
Yeah.
Okay. The
But
basically a theorem is same only here also.
theorem or the theory behind it, yeah,
Yes, yeah, yeah.
yeah.
Okay.
So for the sequences, 1D sequences, there's a lot more theory from signal processing perspective. I don't think we need that from in our particular course. So that's why I also didn't explain it in detail, the theory behind that. Okay, there is another question. The other side. Yeah, the size is actually increasing because we have padded, right? That is the reason which is increasing. If you don't pad it, after convolution, the size decreases. So if you think about it, padding is making sure that you're able to convolve for every element, and hence, since you're padding, the signal size will be more. When you actually don't pad and do convolution, the size decreases. Okay, I think Purna Chandra, yeah, you can unmute and ask.
Yes, the first week session is based on Python notebook. Can you explain with that Python notebook how to solve the,
Yes,
because
yes. So
previous classes I have not attended and the recorded video is also not yet shared.
yeah,
It's
just
already been 3 days or 4 days. We are
Ye-
finding it very difficult.
yes, yes. I'll
That is the reason I requested you to, by morning itself, you please upload the recorded video of this session. It's my request because there is no reply from any of the people from NPTEL.
sure.
After putting 3 to 4 members have put the message like, please share the video, recorded video. No response from any of them. I'm feeling very this thing because last semester also I did one course on essentials of data science. Immediately evening session, morning it was available. Why this is happening? So I don't know. Reason.
Sure. I'll
There is no response from anybody also.
Yeah, I apologize. I think maybe there might be some miscommunication since it's the first week where everyone is just setting things up. I'll just identify and I'll let you know. You'll be getting a link in the forum by tonight or tomorrow morning.
Okay, okay, thank you.
Sure.
Sure.
Any other question? And as for the Python part, right, we'll also be discussing the code today after these questions. There's only one question I think is left. After this, I'll go to the code walkthroughs itself where we'll discuss the basics of Python. Okay. The final question for like in problem solving session. So here it is. Given that this particular filter or thresholding, you can call it, this is a particular thresholding filter. So what does this thresholding filter do? Like you can see, and this is the original image on the left side of Mona Lisa. And after you apply this filter, it basically creates a contrast, like whichever is non-zero value or whichever is greater than 100 image pixel value, it makes it to be 255, and whichever is uh, less than 100, it will make it to 0. So you're just having black, I wouldn't say like extreme contrasted image, you can call this to be. So this particular filter, right, image thresholding, the question is, can you call this particular image thresholding filter a linear filter or not? So the question is, can you represent or call, not represent, can you call this particular thresholding filter as a linear filter or is it a non-linear filter? So we've discussed linearity, I think, during convolution time itself. So just apply the properties of when it can be a linear filter, when it is a non-linear filter. Purnima answered, okay. Let's just wait for everyone else. We'll just give a quick minute. If someone also answered as no. So I think the best for such type of questions, right? Very simple solution is just take any values m and n such that their values actually can satisfy this particular condition. Okay, I think let's just go with the answer. So it is a non-linear function. Why is it a non-linear function? Like, what is the linearity? Linearity means it should satisfy this particular condition. If G is your filter or G is a function in general, linear functions, filters, it's interchangeable. So if you take G to, if G is said to be linear, if G of A plus B is equals to G of A plus G of B. Here A and B are the two images. So what do we mean by that? Let's take an example. Like I said, it's easier to understand with an example. If A m comma n at some mn location, it could be any value, is 90, then this particular G filter on top of A will give 0 because 90 is less than 0. Similarly, if B value is 20, then G of B is again 0 because this 20 is also less than 0. But when you add A plus B at that particular location, the pixel values will be what? 90 plus 20, 110. Now G of this A plus B is not 0 because it is greater than 100, it is 255. Hence, we see that G of A plus B is not equals to G of A plus G of B. So this linearity property is not being is not held. So because of this, we call that this particular operation or filter G is nonlinear. I think pretty straightforward. I hope this is clear. Okay, I think it's pretty good. Okay, then any other questions in any of the questions? Because now let's move on to the coding sessions. So because that has a lot more content to cover since it's all basics of Python also. Any questions in any of the numericals which we did? Okay. So don't worry, this collab notebook, I'll share it along with the PPT also. And in fact, we are trying to create a repository, GitHub repository only, where in that repository weekly, whatever codes we'll discuss, right, in these sessions, those will be uploaded in that. So you can just go to that GitHub link also. Right now, we are still we've created, but there's only 1 week content, so I don't think it will be helpful. Yeah. Please mute yourself. Okay. Yeah, thank you. Okay, so before going into NumPy itself, how maybe by show of hands, how many people are even familiar with what Python is? Okay, sure. I think pretty much most of the people are familiar with Python. Yeah, in case for someone who's not, I'll just briefly give you 1-2 lines. Python is nothing but it's an powerful computer language for like it's a object-oriented programming language, you can say. But nowadays Python has a lot of applications. It's not just for creating apps. Previously it was used mostly for software development, apps and all, but nowadays Python is used for a bunch of different things. It is used for data science, which deals with dealing with a lots of data by data cleaning, data pre-processing, or and for that reason data modeling. And then Python is also used for problems which require a lot of computational a lot of mathematical solving functions. Like for example, if you want to integrate something, differentiate something, or you want to solve any convex optimization, for those also there are libraries available in Python. There are also libraries available in Python for gaming, building your game engines and everything. Obviously it's not just pure Python in conjunction with other libraries. And again, coming to your deep learning or machine learning, for that purpose, your base is Python again. So there are much more easier libraries out there like PyTorch, TensorFlow, which we will cover in these coming sessions in the next few weeks. But all of them, if you think about it, they're all the base for all these libraries is Python again. So I think Python, I think in this today's world, you can't escape, or I would say you can't not work with Python in any whatever field you are in software. You'll always have to deal with Python. So, but in today's class or in these particular course, we'll deal with only a particular functionality of Python, which is Python for data science, you can call it. And in that Python for data science, the one of the most popular libraries is NumPy, or the full form of NumPy is numerical Python. So numerical Python, like the name suggests, right? This particular library is useful to handle a lot of numerical values, which is nothing but arrays. I hope you all are. I hope you all are familiar with arrays. You can think of it like your C language arrays also. Basically, it's nothing but a list of numbers. And since it's numerical Python, you deal with different operations on these arrays, like what addition, summation, sorry, addition, multiplication, finding the maximum, minimum value, or sorting the arrays, and much more bigger operations, which we'll keep on discussing in today's session. So it's a very interesting library for some people who are not familiar with NumPy. I would definitely suggest read the documentation. It's a very good documentation. You'll have a bunch of different there's actually a lot of functionalities that are available in Python in NumPy. So like few of them I've written over here. It's highly used in multi-dimensional arrays. So arrays, like you can think a single dimension array to be a vector. So we all know what is a vector. It's nothing but a single dimension list of values. Now if you have two dimensions, it's matrix. You can handle matrix with NumPy. And beyond two dimensions, you go three dimensions or more, we call it a tensor. Even numpys can handle such big multi-dimensional arrays. So all these things can easily be handled and you can perform faster operations. The second is mathematical functions. Like I said, you can, these arrays, right? You can apply a lot of functions on these arrays. Like you can calculate what is the rank of a matrix. You can calculate with the help of NumPy, or you can calculate what is the SVD of a matrix, or you can also calculate the Fourier transform. A bunch of different things you can do on these arrays or multi-dimensional arrays. Then broadcasting is a popular concept which we'll explain later. Yeah, and also there are also a bunch of different tools if you want to write, if your code is written in C or C++ or Fortran, which are different languages. There are also a bunch of different interfaces available from Python which you can integrate your C++ code. Again, there are a bunch of different advantages. I mean, these are not necessary for you to know the code, but you can always read about it, like how exactly is NumPy advantages in compared to other libraries or languages. Okay, the first important thing before going to that, is everyone aware of what is a Google Colab? Maybe you can again put in chat by saying a yes. Okay, great. I think a lot of people are available of what is a Google Colab. Great. And you guys are aware about using a GPU, how to use a GPU in Google Colabs, right? Okay, I think there is a no. Okay, I think let's maybe I'll just explain, not with GPU. Okay, fine. So what you see on my screen, yeah, with PyTorch. Okay, fine. I think I'll explain what Colab and GPU with Colab is. So what you see on my screen is a notebook. So what is the difference between a notebook? I think someone has a question. Poona Chandra, maybe you can ask your question. Unmute and ask your question. Sorry.
No, no problem. I just raised my hand. That's all.
Okay, sure.
Sorry.
Okay. Yeah. So what you see on the screen is called a notebook. What is a notebook? How is it different from your .py files? So remember, a notebook, as you can see on the top, it has a .ip ipynb extension, whereas your normal Python scripts, it has .py extension. What is the difference between a notebook and normal Python script is, in notebooks you can have codes written in isolations, like paths of code. Like you can see this black color is one component of a code. Similarly, this black color is another component. So when I execute this particular cell, we call this as a cell, this particular block. When I execute this cell, only this particular cell gets executed. None of the other cells before and after gets executed. Now, why is this useful? So imagine if you're writing a very lengthy code that you write in your normal .py files. Now you want to check the functionality, or if there is an error at some part in this code, You want to check at what particular paths is this error arising, or you want to know a functionality of only a certain component or a part of the entire code. In such cases, notebooks are very helpful because you don't have to write the entire code. You can just write the functionality of that particular component, compress it, and write it in the cell component and execute it. That is one basic advantage of notebooks. But you can always read about how notebooks are advantageous to compared to the Python scripts. Python scripts are also very helpful, but it is very different use cases, you could say. Okay, I think there's a question from Kiran in chat. So you will be getting this notebook. I'll upload it as soon as the session is done, and I'll make sure that you get the link for the session for this particular collab notebook, the PPT, and your tutorial videos from mine and other lectures also. You'll be getting it by tonight or tomorrow. But the notebook and all, I'll try to upload it after the session itself. So, okay, now that I talked about the difference between a notebook and a Python, so what does Google Colab do? So Google Colab is one such provides you one such type of notebook which runs on your browser, like your Chrome browser or any browser for that reason. So typically notebooks you need to run it on your local systems, but the advantage of Google Colab is you can run it just by connecting to the internet or using any web browser. So the notebook which gets created will be stored somewhere in a server, Google server. You can't know the exact location, but it will be stored somewhere in the cloud in one of Google servers. So that is the advantage of a Google Colab, that you can access your code or you can run a code from anywhere in the world if you just have access to internet and a web browser. Now, Google Colab obviously comes with different specifications. You can run your particular Google Colab with just a CPU, or you can run a Google Colab which has a GPU extension. So if you press connect over here, usually, so this when I press the connect, so this will basically find a particular, you can assume it to a slot on the server on the Google Cloud, and gives me an allocation of a particular type of a CPU system which is present in the Google Cloud. So now it's at connected, and then when you click on this, when you click on this, you can see the different on the bottom. You can see what is the RAM that you get. So you can also see the 12.7 GB of system RAM I got allocated, and 107 GB of this secondary memory, disk memory I got allocated. I can use all of these. Basically, depending on your application, you can always request for higher RAMs and higher memory. This is okay, but now if these are all CPU, there's nothing GPU. If you want to connect to a GPU, you should just click on this particular button, and there's an option called as change runtime type. When you click on this, there'll be a bunch of different options. You can right now I have a CPU that is the most basic Google Colab component or subscription you'll get. The other one is T4 GPU. So I mean, I'm not connecting to it right now, but T4 GPU basically provides you, there's a particular type of NVIDIA GPU called T4. It provides you on the back end that particular GPU. There are also other GPUs, A100 and L4 GPU, which are not available for me because mine is not a pro subscription. So depending on how much money you pay, you'll get better and better GPUs. For the free version, you get one CPU access, and you can also get this basic T4 GPU. So this is a basic understanding of a Google Colab notebook. Okay, yeah. I think there are some questions here. Yeah, Jyotirmay, like I was saying, and even Gayatri. So these recordings and notebooks, they are actually, you'll be getting an Excel sheet link with all these recordings and notebooks with their Google Drive links in those Excel sheet. That Excel sheet link, I believe, is not yet shared with you. I'll make sure that it'll be shared with you by tonight. Okay. Okay, there's a question from Niharika. Maybe you can unmute and ask, Niharika.
So I have got to know about this course today. So like last day to register this course was yesterday. Even though everything was open, I was not able to, like, I think I won't be able to write the exam, right? Or will I get the updates for this course?
So firstly, like logistic questions about the course examination, we are not aware of it because we are TAs, we are just PMRF TAs who will be dealing with the live sessions. Those are different TAs, NPTEL TAs. Maybe you can mail the NPTEL office for such questions. So because we are also not aware of what are the conditions for exam registration. So logistics of especially those particular exam registration or course registration, we are not aware of it. You need to mail to the NPTEL office.
Okay, fine. Thank you.
Yeah. So any other logistics also, kindly just wait till the session ends so that others won't get disturbed. Okay, like I said, the first thing you need to do is install NumPy in this, and the command is pip install NumPy. Most of the times when you get a Colab notebook, most of the basic libraries will be installed, like NumPy, Matplotlib, or other different libraries which we'll use. Most of the basic things will be installed, but just in case if it's not, you need to install this using this pip install command, pip install NumPy. And after you install, the first but important thing you need to do is import this particular library. That is the most important thing. I mean, that's common across any programming language. If you want to use a library, import that library. It's the same over here also. So it's usually a standard practice to import NumPy as this alias np. Don't ask me why. That is how it's been happening since decades. People just import NumPy as np because it's easier to write np when you're writing longer codes. So that's why people always import NumPy as np. I would also suggest follow this practice because it will be very helpful when you write bigger codes. Okay. Now let's go to the actual concept of NumPy arrays. So you all must be familiar with list. Now, what is a list? A list is nothing but it's a 1D array. Like you see this particular numbers, right? 1, 2, 3, 4. This is nothing but a list. List is nothing but a arrays plays in a particular data structure. List is a type of data structure of Python. Now to convert from list to a NumPy array, this is the command np.array, and then you enter whatever list it is. So this now converts the standard list data structure in Python to a NumPy array. Can anyone guess why do we even need to convert into a NumPy array? Why can't we do all the why can't we just use list? Can we even use list for more complicated operations, mathematical operations? Yeah.
No, sir. We cannot use list because list will have different data types, whereas NumPy array, all the data types will be same. So storing, accessing is easier.
Sure, that is one reason, and also it's the calculations. You can't do numerical operations on list. You can't do complicated mathematical, operations on list. List can do very basic type of operations. NumPy can do much more complicated, and like someone also written faster calculations. Okay, so this is a simple one-dimensional array which you created. Now, if you want to create a two-dimensional array, similarly, you go from a 2D list. If you've taken list data structure, you just create a nested list, we call. You create this list of list, and then you send this as an input to np.array. Now, what gets printed is the 2D array. Okay. Similarly, you can also create a NumPy array from a tuple. Tuple is another type of data structure of Python. You can also convert any tuple from Python data structure to a NumPy array. Now, the basic, what are the different, I would say, like functionalities, built-in functions that are available in NumPy that you can do on these arrays? These are the most standard, I would suggest. I'll just explain one by one, and we can see the code also in the below cell. Okay, what is the first one? It is arrange. What does this do? Basically, it will create a particular array starting from a number to a particular end of a number with a particular step. So I'll explain that more with the example. So if you look at the first one, np.arrange 5, 15, 2. So what it says is you create an array which starts with the number 5, goes up until 15, and it should not go in step order of 5 in one step. It should do every 2. It should skip every 1 and store the other value. So that's why the value is 2. The stride is 2 basically. Step is 2. So what will it create? It will create the array which you printed 5, 7, 9, 11, 13. So this is a basic functionality. So sometimes you don't know what type of a list you want to create, or sometimes you just want to create a lengthy list of just incremental numbers. So you can use this particular function np.arrange. Next is linspace. This also generates the same, but here you generate between a range of numbers. Like here you're generating 0 to 1. np.linspace 0, 1. So you're generating an equally spaced numbers between 0 and 1. And what is the last argument? It says how many such points you need to generate between this 0 and 1. So what will be the output? Output is basically 0, 0.25, 0.5, 0.75, and 1. So you created an array of 5 elements between the range of 0 to 1, and they're equally spaced in this range. All of them are equally spaced with the difference between them as 0.25. Okay, next comes np.0. np.0 is, as you can expect, it's nothing but it's creating an array filled with all zero numbers. And you can just use this np.0 is 2 comma 3. So it will create a array of 2 rows and 3 columns, and all of the elements in that array will be 0. np.1 again is the same thing. It will create an array of a given size with all the elements as 1. np.I is nothing but it will create a matrix or an array with a identity matrix. So it basically creates an identity matrix of a given size. So if I say np.I3, it will create a 3 by 3 identity matrix. I'm well aware that every one of you know what an identity matrix is. And then full. So this is, it says that you can create any array of a given size with a particular value. So if you look at it, I'm creating over here an array of size 2 comma 2, and all the elements should be of the value 7. So if you just print, right, you see all of these values for different zeros, all zeros, ones, all one. This is an identity matrix, and this is a full matrix. Okay, I'll just quickly pause for a second. I think there is a question. Arrange is similar to Python. Arrange is different from arrange. So this is a single R. That is different. Arrange is, I am not sure about if there is a ARR arrange. This is a different one. This is AR range. You can consider a range kind of a thing, not the arrange. It's a bit different, the spellings. So this creates, what do you say, an incremental values in that particular array. Slicing, that concept comes next. I hope this difference is clear, Ivan. Okay. Now let's go to some attributes of this particular arrays. What are the attributes which you can usually want to know about a particular array or a data type or a data structures? What is the shape? That's the basic thing. Like I need to know what is the shape of my array. To know that, you can just first create, like we just created some temporary arrays, and you just print dot shape. This is an array 1D. You just do array 1D dot shape. What it will return? It will return what is the shape of that array. That shape could be a 1 dimension, 2 dimensions, or multi-dimension. Now D type basically it says what is the data type of the elements in the array. What are the different data types? You might be aware. You might be aware of integer, int, float. Float also has different, float 32 and float 64. Those are basically number of bits you can use. Then there is again complex data type also, which is available. So a bunch of different data types are available. How do you get to know them? Same. You do array1d dot d type. It will print what are the different, what is the d type of the elements in this particular array. Next comes what is the dimensions of this particular array. So the dimensions is what are the number of accesses, or what are the number of, like what do you mean? So a difference between 1D vector, it's 1 dimension, and matrix is 2 dimensions. Like it has 2 axes, right? You can call it the row axis and the column axis. Similarly, a 3 dimension will have row, column, and you can consider depth. So those are nothing but dimensions you can consider. So dot ndim tells you how many dimensions this particular array has. It is different from shape. Shape gives you the actual shape, like what is the size kind of thing you can, what is the shape, as like, is it a 3 by 2 matrix, or is it just a 1 comma 4 vector? That is the shape. Dimensions are again different. How many such accesses are possible, that will say dimensions. Then size basically says what are the number of elements that is present in the array. So that's a very simple attribute. What it just counts the number of elements and it just prints. So you can always take a look at this. We have just created a bunch of different types of arrays, and you print all of these attributes. You see different shapes, right? The first one was a single shape, 4 comma none. And then you have their D types, number of dimensions. Since it's just a vector, 1 dimension, there are only 4 elements, so 4. Similarly, we do it for all the other examples. So I'll again quickly pause. Attributes are clear, or is there any questions on the attributes of arrays? Okay, great. So moving on. Then we talk about indexing and slicing. Okay, now why do you need indexing and slicing? Basic thing is, if you have a array of a lot of numbers, but you're not interested in performing an operation on all the elements of the arrays, you want to maybe perform addition on row 2 and 3, and you want to perform multiplication of row 100 and 200. Like you want to do specific operation on specific elements or like a sequence of elements in the array. In such cases, indexing or slicing will be very helpful. So indexing, like you can see, it's a basic. Every array has a, like I said, array is nothing but a bunch of elements. Each element is a particular index. So for example, if you look at this array consists of 4 elements: 10, 20, 30, 40. So what is the index values of these four? 0, 1, 2, 3. So always remember, in programming, your indexing starts from 0, not from 1. In mathematics, like in general mathematics, we always start from 1. So there's a, you might get confused. Always remember, programming indexing starts from 0. So these are the 4 elements. Indexing starts from 0, 1, 2, 3, and the elements in those are 10, 20, 30, 40. Now, if I want to access only the 0 element of the first array 1D, I'll just write array 1D in the square brackets 0. If I want to access the third element, I write array 1D square brackets 2. 2 because the indexing starts from 0, so the third element will be at an index 2. So very simple for 1D array, very intuitive also. For 2D array, it's a little bit more complicated, but again, you can, it's the same concept which goes. In 2D, this is a 2 cross 2 matrix, which elements 1, 2, 3, 4. Now, in a matrix also, when I say A, I, comma, J, right, the ij decides which position is present in that matrix. Similarly, you can assume this I, comma, J is what the value we are representing when you are printing or indexing this particular 2D array. So when I say array 2D 0, comma 1, I am selecting the second element. What is the second element? It's at the 0th row and the first column. Similarly, if I say 1, comma 0, we are indexing an element in the first row and the in the second row and the first column. So very simple. This gets tricky when you have more and more dimensions. When you create arrays, right? Then it gets a bit tricky. So indexing, you're accessing a particular individual element. Now, if you don't want to access individual element, now you want to access a sequence of elements. Like maybe I want to access elements from 2 to 20 to 40. Like I want to index from all the elements after the first element. How do you do? We need to go to slicing for that. So slicing helps you access a range of elements instead of a single element. So basic type of slicing is where you provide this colon. Everyone is aware of the symbol colon. So when you give a colon between two numbers, it means that your starting index value is 1. That will be included in the new array which you created, and you go up unto third element, third indexed element, but you don't include this third index element. So for example, if your array was 10, 20, 30, 40, and if you want to slice from 1 to 3, you include 20 and you include 30. The third element, the third indexed element 40, you won't include. Why? Because the last, in this indexing, the last value which you mentioned, that is not inclusive. It's a open bracket for people who are familiar with maths. So you don't include the element whose index is present in the value after the colon. It starts off from 1 and 2. That's it. The two values will be indexed. Now, similarly, you can do that for a 2D array also. Here, if I write 0, comma, just a colon. So there are two dimensions. I would point you out to the difference. In the first one, we didn't keep any comma. So it means that this indexing is happening only in one dimension. Now, when you have a comma, the first dimension has its own indexing. The second dimension has its own indexing, slicing happening. So for the first dimension, you're just doing indexing by selecting one element, which is the first row. For the second dimension, now you're slicing. You want all the columns from the first row. That is what this means, 1, comma 2. Similarly, the third, here what we're doing is we are selecting all the rows, basically the two rows, but only the first column. So that's why you get 2, comma 4. So if you see the matrix is 1, 2, 3, 4. When you're selecting the first row, what will you get? And all the columns, you should get 1, 2. That is what is getting printed. In the second time, what we did, we selected both the rows, but we are selecting only the second column. So what is the second column, both the rows? 2, comma 4. That is what is getting printed, 2, comma 4. Okay, I think I'll just quickly pause for a second. Anything unclear in slicing or indexing? You can maybe raise your hand or unmute and ask or put it in the chat. Okay, great. So if this is clear, then let's go to Stride. Yeah. So stride basically it says that how many, like for example, if you want to access the elements in a particular array, but at a particular what do you say interval of time, like you want to access every other element in your array, so you just have this double colon 2. So different formats are there. I would suggest just reading upon stride. So if you have double colon and 2, it means that you're accessing every alternate element in your array. The what was the array? It was 10, 20, 30, 40, right? So if I since I did 2, you're skipping one element. So initially it was 10, you're skipping 20, you're then selecting 30, skipping 40. Now this is another type where you, for the first dimension you're having double column -1, and then the second dimension also you have double column -1. So what does this double column -1 do? It basically reverses the row. So what was the rows? Initially the rows were 1, 2 and 3, 4, right? 1, 2 was on the first row, 3, 4 was on the bottom row. So the first reversing happens between that. You flip the row 1 to be row 0 and the row 0 to be row 1. And in the column also you're reversing. So which the column 0 will now become column 1 and the column 1 will now become column 0. So these are the different types of stride options. You can always Google more different types of variations in this stride. It's very helpful when you have to reverse, or you want to, for example, the flipping, right? You all remember the convolution operation in that you first double flip your kernel. That's what Sir said. How can you easily double flip? You can use this stride option. If you do this, you can quickly double flip it. I mean, not this particular exact command, you'll have to do a little bit more manipulation, but you can easily double flip. Okay, then moving on, Boolean indexing. So what does Boolean indexing mean? So it's like conditional expressions. I'm assuming you all know the if conditions, right? If conditions is when a particular condition is satisfied, then you go into that first if loop. Otherwise, you go into the else loop. So here, how can you use such type of conditional expressions for indexing? So given you have the array 10, 20, 30, 40. So you just say, I want to print all the elements from this array which are greater than 25. Very simple. In just one line, you just write that and it will print 30 and 40. So you can do any kind of condition expressions, equal to, less than, greater than, equal to, a bunch of different, not equal to, all of those things. You can just quickly do it in this particular syntax format, and you can identify all the elements which are satisfying this condition. So if you want to do a more fancy type of indexing, so when is this useful? For example, you have your data set, which is like 10,000 rows and 10,000 columns. And then you get another type of data, which is basically containing all the indices you want to extract from this original data set. Now, let's call that indices array. So your array 1D is your original array. Indices 1D is an array that consists of all the indices that you want to extract. How can you do that? You just use the syntax array 1D square brackets indices. Then it extracts all the all the values which are present in this particular in this element which is present in indices. So 0 to 1. What are the elements? 10, 30, and 20. So in the same order, in what order you wanted to pick, right? 0 to 1, it will print in the same order. So this is a fancy type of indexing. Okay. I'll just quickly stop over here before we move into basic operations. Any further questions on slicing, indexing, or for that reason, attributes, what is an array? You can just let me know. So the first sessions, I mean, since I want everyone to understand what is NumPy and Python, so it is a bit basic. I can understand that this is nothing to do with the modern day PyTorch and all, but understanding these will give you an idea of how these, data sets, or what are the data structures that are being happening when you write your code in PyTorch, right? You'll get a lot of idea what are these arrays, tensors that you're creating. So it's always helpful to understand these basic data structures. So yeah, any questions or anything? I'll just quickly pause for a second. Okay. If there are no questions, let's move ahead. So let's start off again. Basic arithmetic operations. What are the basic arithmetic operations you can think of? Addition, subtraction, multiplication, division, exponentiation. So what is addition between two arrays? You don't have to write a for loop or anything. I mean, in simple C, you used to write take element first element from the first array, second element from the second array. You can simplify it. You can just write array one plus array two. This is present in most of the high level uh, programming languages. And similarly, you have array one minus array two, which does your subtraction. Similarly, you have array one into array two. All of these are basically element wise. Remember that. So it's not any fancy arithmetic operation. All of these are element wise arithmetic operations. For people who are not aware of it, element wise means pick from each element, like one to one correspondence, 1 into 4, 2 into 5, 3 into 6, like that. Similarly, division is also element wise. And then there is exponent. Basically, exponent is to the power of. So when you write array 1 double star 2, every element in array 1 is raised to the power of. So 1 square, 2 square, 3 square. I think these are pretty standard. I'll go into more mathematical functions. So, like I said, there are a bunch of mathematical functions. These are not exhaustive at all. These are just a small representation. You can always look into the NumPy documentation. So, what are the different functions? You can have a sign function. So, when I say np.sign of this particular array, what does it create? It creates element wise sign of that particular element. So sign of 0 is what? 0. And sign of np.pi2. So like I said, NumPy also has a special variable called pi, which is basically your mathematical symbol pi, right? 3.14 so and so. So that is represented as np.pi. So sine of pi by 2 is what? Sine of 45 degrees, which is 1 by root. Similarly, sine of pi, pi by 2 is 90, my bad, which is 1. Similarly, sine of pi is what? 180, which is again 0. Similarly, you can do for cosine also. And then you can also do your logarithmic and exponential functions. np.exp is your exponential functions. That is nothing but e raised to the power 1, e raised to the power 2. And then there is your logarithmic function, log of 1, which is 0, log of 2, log of 3. Interesting, you can also change your base also. I would suggest look into this log function documentation. You can give your different bases like log 1 to the base 10 or log 1 to the base e. By default, it is e, but you can also change your base of log. Then there are again different functions like absolute values. You're all aware absolute values is it returns, it takes a negative value, returns a positive value. If positive comes, it returns as it is. So absolute value of element wise arrays is np.apps. Then you can also take the square root of this value. So you need to follow certain mathematical rules. Square root always happens when the input is positive. So that's why we first make it positive and then we send it to square root. If you avoid those mathematical rules, right, you'll get an error. So make sure you're following the mathematical rules when you're using mathematical functions. Okay, great. I think there are a bunch of different functions. I think you can look into it. I'll keep moving in the interest of time. Then we come to something called as broadcasting, which is actually very helpful and very interesting concept, which is probably not there in other programming language as far as I remember. But yeah, nowadays there might be compatibilities available. But yeah, coming to NumPy broadcast, what does broadcasting even mean? So for example, if there's a like if there's no compatibility between two arrays, like what do you mean by compatibility? If array 1 is of shape 3 comma 2 and array 2 is of shape just 3 comma 1 or just 3, so there is a mismatch, right, between the shapes, and you want to do operations like you want to add these two arrays or you want to multiply or whatever you want to do operations between these two. How do you do? Either you expand this array 2, which was 3, right, you expand it 3 times in the column and 2 times and make it 3 by 2. That is one way, and then you apply. But instead of going through all that, you can directly use the broadcasting option. So you don't have to do anything per se. NumPy inherently does your broadcasting operation. So what do I mean by that? So if I have this example, array 1 is of the shape 3, array 2 is of the shape 3 comma 1. So now if I add, right, array 1 and array 2, automatically you are broadcasting this 3 vector into having this column like 3 comma 1 shape. And then you do the addition like 4 plus 1, then 2 plus 4, 3 plus 4, which will be the first element. 1 plus 5, 2 plus 5, 3 plus 5, which will be the second. 6 plus 1, 6 plus 2, 6 plus 3, which will be the third. Similarly, you can do for multiplication also. If you have two shapes, 2 comma 2 and 2 comma 1, broadcasting inherently happens. And then this broadcast is this 2 comma nothing, right? The array 2 is first broadcasted to have 2 columns, and then it does the element wise multiplication. Then you get 10, 40, 30, 80. So how does it broadcast? Basically, it replicates the values into having more dimensions. That is the broadcasting. So it's explained over here. Array 1 is expanded 1 comma 2 comma 3, 1 comma 2 comma 3, 1 comma 2 comma 3. This is for the above example. Array 2 is expanded to 4 comma 4 comma 4, 5 comma 5 comma 5, 6 comma 6 comma 5 before the addition. Now you do element wise addition. Similarly, here also you expand it that way. So I hope broadcasting is clear. There are certain set of broadcasting obviously that you need to follow. So there are a bunch of different broadcasting rules. I think in the interest of time, maybe I'll move ahead. There are a lot of different concepts. I would definitely suggest you all to read each of the rules that are present for broadcasting. You can't just expect all the broadcasting to happen all the time. Just read on when broadcasting happens, when it fails. And if you have any questions, we can discuss it in the next class. Okay, let me then go to another functionality of NumPy arrays called array manipulation. Okay, what is array manipulation? Like, what is the first type of array manipulation? Reshape. What do you mean by reshape? Now, if you have a array of, let's just say, example which is there, right? If you have an array of size 12 elements are there, which is in a single vector. But now you want to break that vector and create a matrix which is having 2 dimensions. How do you do that? You can either have 3 rows, 4 columns, or 4 rows, 3 columns. That is one way. You can also do 2 rows, 6 columns, 6 rows, 2 columns. Whatever is the proper breaking down factor, you can always use that. So the same thing, that's what reshape does. So if you have your original array, which is np.arrange, which has 12 elements, then you use dot reshape function and you reshape accordingly. 12 can be broken down into 3 comma 4. So you do that reshaping and you mention what are the dimensions that you want, 3 comma 4. Always remember, please, when you're breaking, right, reshape, make sure that the values can be broken. Like 12 can be broken into 3 comma 4. You can't just write 5 comma 10 or something. Then it'll throw an error because you can't break 12 into 5 comma 10. So then after reshape, then something is called as flatten. Flatten, as the name suggests, it is nothing but if you have multiple dimensions, right, more than 2, 3 dimensions, your array, if you want all of them to just have one big vector, all the elements is just in like one big flat vector, you just use flatten. So this entire array, right, this 12 elements, which was previously in the shape of 3 comma 4, when you flatten it, you just get a one-dimensional vector, one-dimensional array, which is 0 to 11 values. Again, the number of values remains the same. So that is also important. Then there's something called as ravel function. So ravel and flatten does the same thing, but there's a small difference between them. So both of them basically flattens your array. Both of them takes any multi-dimensional array and just generates a flattened one, flattened array. But the only difference is ravel doesn't create a copy of the original array. It actually, if you change any value in the ravel array, right, the original array also gets changed. Whereas for flatten, that is not the case. Flatten creates a copy of the original array. So that is one advantage you can say, because sometimes you want a particular change in the ravel array to being done in the original array also. Then you can use ravel. If you don't want that, if you want both of them to have separate operations or changes, then use flatten. But the functionality is the same. It's just that one creates a copy, one doesn't create a copy. Okay. I think there's a question. Sir, is there a study group? I'm not aware of a study group, Kiran, but I think the forum is a place where you can ask. Maybe students can get together on their own on WhatsApp or something and create a study group. I don't think there is any official study group as far as I know. You are aware of the Google forum, right, where you can ask questions for the course. So just post it over there. It should be helpful. Okay, moving on from the ravel function and flatten function. Now transpose, again, this is the basic matrix linear algebra transpose which you do on matrices. So if you have an array 1, 2, 3, 4, 2, 2 array, if you transpose it, it's basically what the normal matrix transpose. The rows become columns, columns become rows. So previously 1, 2, 3, 4 now becomes 1, 3, 2, 4. Another here, this is a different thing which is called swap accesses. So swap accesses basically now in your multi-dimensional array, this is usually useful. If you have your original if you take a 24 numbers 0 to 23 basically, you first reshape into having this three dimensions 2 comma 3 comma 4. What does it mean? There are two rows, three columns, and four values in the depth dimension. So there are three dimensions, right? So there's row, column, and the depth dimension. So these are the different values present at each dimension. Now, if you want to swap any of these two dimensions, like you want the depth to become rows, or depth to become column, or column to become rows, you can just write np.swap access, give the input which array, and then you mention which of the two arrays you want to swap. You mention 0, 2. So now the the first array, axis, right, gets swapped with the third axis. So what will be the output? 4, 3, 2. The shape of this particular new array which you got, it will be 4, 3, 2 because the last dimension is swapped with the first dimension. So the elements of all those depth will now become rows, and all the previous rows will now go into the depth dimension. I hope this is clear, right? I'll just quickly pause because swap access is not something very common like transpose, but I hope you got the idea of what, why you are swapping, how you are swapping the accesses or the dimensions. Okay, I think if it's clear, let's move. Then comes the concatenate function. So basically, concatenate, like the name suggests, it is when you combine two arrays. And how do you concatenate? You can concatenate any dimension. If you just have two dimensions, you can concatenate row wise or column wise. Or if you have more than two dimensions, you can specify a dimension at which you can concatenate. But make sure when you're concatenating, all the dimensions match, because you can't, if you, for example, you have three columns in a particular array 1, and if you're concatenating array 2 which has just two columns, you can't do that. So always make sure that concatenation happens with proper type of shapes compatibility. So in this case, you have two rows and two columns, 1, 2, 3, 4, and you have another array which has just one row, two columns, 5, 6, and I want to concatenate them row wise. So this will be the final output 1, 2, 3, 4, 5, 6. So this is a basic type of concatenation. There are obviously a bunch of different functions. How do you want to stack them horizontally, vertically? If you want to split your arrays into sub arrays, then if you want to split it into horizontal sub arrays or vertical sub arrays, a lot of functions. I've just listed out all the important, I would say, which you can, you'll be using throughout this course. Just go through all of these functions, take a random examples, and then you keep on applying these operations and see how does each of these particular function perform. Again, similarly, if you want to add and remove elements, like you in a list, right, you append. Similarly, you can append elements into array. You can use insert function at a particular index. You can delete values from your particular array. Resize is again something like reshape, but it will resize and fill the copies also of the original data. This is more sometimes helpful when you want to expand your array. Repeat is again creating a copy of a particular column or a row or another dimension multiple times. Unique is identifying all the unique elements in your array. So yeah, all of these are important functions. Just go through it. Now let's go into multi-dimensional arrays. So right now, up till now, I just talked about 1D, 2D, but like I said, there are more than two dimensions. So the first one is a simple example of a 2D dimension. This is a 3D dimension where if you want to create 3D dimension, it's a nested list basically. From a nested list, there are list of a list of a list basically, you can call it. So you have the three square brackets starting off with, then you mention all the elements, and then you end off with three square brackets. So here the shape is 2 comma 2 cross 2 cross 2 of this particular array, which is three dimensional. Like usually you can use all your basic functionalities which we discussed till now on these multi-dimensional arrays. Like if you want to create zeros, all ones, you can always just mention the number of dimensions you want to give. Similarly, if you want to index, slice, same operations which we talked on the top, you can always use the same logic in these multi-dimensional arrays also. I'm just moving more ahead because it's the same concepts. It's just that we're doing it on a higher dimension. Now let's come to matrix operations. So what are the basic matrix operations you can do? It's basically calculating the matrix element wise products, right? Sorry, matrix multiplication. Like if you want to multiply a into b, So you take the first row and multiply with the first column, and then you sum elements. Then similarly, first row, second column. That's just actual mathematical process, right? So that is basically represented with NP dot. When you do NP dot or A comma B, it will basically do that matrix multiplication between A comma B. So just look into these. Both of them do the same matrix multiplication, but matmul has a bit of rules regarding broadcasting, if you remember broadcasting, right? Whereas dot doesn't have. So even if the shapes mismatch, if you all remember, matrix multiplication happens only when the shapes match. Like the column of the first array should match with the row of the second array. That's what matrix multiplication requires. But if you do np dot, broadcasting adjusts that, whereas np.matmul function doesn't do it. So just take a look at the difference between these two functions. Okay. Coming to another very helpful and useful is random functions. So why do you need random functions? Like, why do you have to generate? Like I said, going ahead in the course, you will see a lot of places where you want to just generate randomly your parameter values, and then you optimize it, those random values, to get the best optimal value to solve that particular function or process or task. So usually even in your normal, like, probability processes, or in general, whenever you solve any optimization technique, a thumb of rule is you start off with random values from a probability distribution, and you do all your processes, learning process or whatever. How do you generate that in computer? You basically in particular NumPy, you use this function called as np.random.rand. So rand generates random numbers from Gaussian distribution, and sorry, rand generates from a uniform distribution with the intervals 0 to 1. Similarly, if you want to use randint, this generates integer random numbers between the range whichever you specify, 1 to 10 or whatever range you want, again from a uniform distribution. Rand also generates from a uniform distribution, but this could be a floating point number. Floating point number is nothing but a decimal number. Integers, like you all know, it's a non-decimal number. Similarly, you can also generate Gaussian from a Gaussian distribution. You can generate, that is rand n, and this is a standard Gaussian distribution, which means that the mean is 0 and variance is, standard deviation is 1. So from a Gaussian random distribution, you can generate 10 values using this particular command. So these are the 10 values that follow the standard normal distribution. Again, we are not limited to this. You will find questions on your assignment also. Similarly, I would definitely suggest looking into random. So this is a very interesting area, how to generate different random numbers, arrays, basically. Okay, moving on. There's another function called as choosing from arrays. So it's basically if you want to choose a particular elements without, like, you if you all remember the basic probability questions, right? What are the basic probability questions? Imagine you are given a bag with different what is it, toys or balls or fruits, and you're asked to sample each one, and sometimes you can sample with replacement. That is, you can pick a ball or a toy, and then you see what it is and you keep that back in the bag. Sometimes you sample without replacement. So imagine sampling that bag and everything. How do you sample that from an array? That is what choice says. How do you sample elements from a given array, and how many samples you want, and do you want to sample with replacement or without replacement? Just picking elements from this array randomly. That is what sampling does. That is what choice does. So sampling from this array randomly, how many times, and with and without replacement. So all of your basic probability distributions are again available as functions in this particular library NumPy. So your standard uniform distribution, Gaussian distribution, exponential, Poisson, binomial, chi-square, all of these and a lot more are available. You can just go through each of these functions and get to know about them. Okay. Then there is something called as random set or random seed. Sorry. So what does random seed do? So when you're generating these random values, right? So they always they generate from a particular process. Underlying process, it's a bit out of scope. You most likely generate all of these from uniform distribution, multiply with certain values, and then make it like a Gaussian distribution or other distributions. But there is a process. Sorry. There's a process using which you randomly generate these random arrays or elements. So when I fix this seed, right? For example, if I'm saying my seed is 42, So what happens is, why do you even need to fix this? Sometimes the random numbers I generated in my particular notebook and the random numbers you generated will obviously be different because they're randomly generated. But when I fix the seed 42, the random numbers which I generate and the random numbers which you generate, giving the keeping the same seed number, will get the same values. So this will ensure reproducibility. Now, is reproducibility important? Yes. So, for example, how is it important? I'm assuming you all have taken machine learning, right? So, in what do you do after you train your model? You report your accuracy. Most of the times, most of these machine learning processes depend on some random values. So, it could be either randomly splitting your data set into train and test, or some other randomness element in your model itself. So, when you fix the random seed, if I am saying that I got 40% accuracy or 50% accuracy using this particular random seed 42, and if you use the same seed, you'll get the same percentage of accuracy. Whereas if you use a different seed, you'll get a different accuracy. I mean, it could be like few percentage less or more also. So seed is very important to ensure that reproducibility of models is maintained across the across different environments and hardware systems. So always remember, set your seed. Even in all your coding assignments which you'll get, you'll be given a clear instruction that don't change the seed, because if you change the seed, then what answer we are expecting, right, to be the correct answer, it won't be the correct answer because your random process started off with a different value. Your random array got a different values than the random array which we got. So always remember, set your seed value or fix it and report when you're writing a paper or when you're deploying your models also. Make sure you report what the seed value you used so that other people can reproduce it. You'll understand this more and more when you learn about the models, right? In this course, you'll understand where this randomness comes from. Okay, and then again, like I said, there are a bunch of different linear algebra modules present in this NumPy. Like what type of operations you use in linear algebra? First basic one is determinant. You can calculate a determinant of a matrix, right? So same thing you can calculate with the arrays also. You just have to use alg or linear algebra is a function name in MP. So and determinant is the base operation which you want to do from this particular function. So np.linalg.det gives you the determinant of this particular array. Similarly, you can also calculate your inverse of a matrix. Like I said, please follow the mathematical rules that are meant for these operations. Like you can't calculate the inverse. I mean, you can't calculate the inverse of a non-square matrix. You need to use a pseudo inverse concept or a bunch of different rules which you follow for these operations, which in mathematics you need to follow them even over here, otherwise it won't work. Similarly, you have systems of linear equations, right? You usually solve that using some I think Gaussian processes, or Jordan normal forms, or we call different systems of linear equations you can solve using these processes. All of them you can also solve using this dot solve function. You can mention what type of process you want to use also. Just look into this solve function. You can also mention if you want to use a particular type of solving process to solve this particular equations. Similarly, you can calculate your eigenvalues, eigenvectors. So today in one of the questions, right, what are the singular values? Singular values are nothing but the square root of eigenvalues. So if you ever want to calculate the if you're given a particular kernel and if you want to calculate the eigenvalues to determine whether you can separate that particular kernel, right, you can just use this function np.linalg.eigen. You'll get to know what are the different eigenvalues, and the square root of that is your singular values. So bunch of different again operations, your norm calculation, vector norm calculations, then your SVD, the entire singular value decomposition process of a matrix. All of them are present very nicely with just a single command. You can do all of these. Otherwise, you might be knowing how complex the process is when you have to calculate these things by hand. Imagine when you have to do it for very big arrays, right? Like 10,000, 10,000 or 1 lakh, 1 lakh. Those are again very common types of data sizes in real world. So you can't do them by hand. So all these functions are very helpful. Now, finally, let's move into the core of this particular course, which is images, computer vision course. So let's see what are the different libraries, basic libraries that you need to know that will help you work with images. So before going to that, so any doubts in NumPy library? Because pretty much we've covered a lot of different functions and attributes and operations. I'll just quickly pause for a minute. Any doubts or anything about NumPy? Could be anything. Yeah, Mishkat, I think. I'm sorry if I'm pronouncing your name wrong. Yeah, please unmute and ask.
Actually, you are not wrong. That's Meshkat. But
Okay.
do we need PyTorch for assignments, or we need TensorFlow?
Okay, so for the first, I think 2 weeks, you don't need any of them. First 2 weeks, you can basically use these NumPy libraries. That should be fine. Like from week 3, when the actual deep learning starts, right? From there, we use PyTorch. I think the entire course is based on PyTorch. I don't think we're using TensorFlow.
Okay, thank you.
Excuse me, I have one question.
Sure.
In question number 5, 6, 7 of the assignment, where we have to read an image of humans. I don't know. Can you just roll back to question number 5, 6, 7?
So is it assignment 1 or assignment 0?
Yeah, assignment 1.
So we can't discuss assignments before its due date. We were given strict instructions from the NPTEL office. You can discuss it after you finish the submission deadline of the assignment.
It was not like I'm discussing assignment question. It's like when I'm loading the image from the schemage dataset, it is giving me an error. So until this error is resolved, I'm not able to finish question number 5, 6, and 7.
Yeah, but again, I don't even have the assignments because we don't create the assignments. Those are different TAs. Those are NPTEL TAs. We are PMRF TAs who just work on these live sessions. So I actually don't have access to those assignments also. But if you have any questions, you post it on the forum. You have a course
Yeah,
forum.
I have posted it. Because
So
that's not related to like I'm asking the answer of the
yeah, I
question. It's
get
like-
that. I get that. But usually because I don't have access to the assignment, I also can't show you anything. So you post it on the forum. I think
I can
someone
ask
should
you,
reply.
it's relevant to schemage. If you import schemage as IO, suppose, and
Okay.
then schemage dot dataset dot human was I don't know. I searched it a lot, but it was giving me some error like you have to install Pooch or something like that. So I did that as well, but still the same error. So I posted
Ideally,
it.
so maybe you can take a look at this collab notebooks, right? It can give you a better understanding of how to do that. Because here we are using the ski image, because there should not be any dependencies. You install the library ski image and it should work. And are you doing it
Yeah,
on your local system or?
it is from the dataset of the schemage itself. So it's not like from the local system. It is from the dataset itself. Schemage dot dataset dot the name of the image, and still it is showing me the error.
See,
So I
so that's my point. If it's an error which everyone is facing, there's because the TAs must have created, they should also face if it's the same Google Colab notebook, right? So just wait it out. If no one is responding, I'll also contact them to look into this question. But if none of them are facing, then maybe just look into it again. Because if it's an import issue, all of them should face the same import issue.
maybe, but that code is not written by me. It's already written in the collab. If I try
Yeah,
to run that,
that's what I'm saying. So everyone should face that issue. If then they're not facing that issue, we should look into what you're getting. I would suggest.
yeah, let's go
Yeah.
ahead. Yeah,
Sure.
thank you.
Any other questions?
No, it's good. Fine, thank you.
Okay. I think someone just answered something in the chat. Maybe you can look into it, Virendra. Okay, moving on. Let's talk about images as a matrix. So, as you know from your lecture, in the week 1 lecture, professor has discussed that every image can be expressed as a matrix. So it could either be a simple two-dimensional matrix, which is usually a black and white image with just rows and columns, or it could be a three-dimensional, which is color image, RGB. The depth dimension is that red, green, blue channel. So, and then each of the element in that particular matrix or array, two-dimensional array, now that you know what arrays are, is the pixel value of that particular image. So the pixel value is like, it ranges between 0 to 255. And if you want to normalize it, it can go between 0 to 1 also. before going to how to import images or work on images, the important things are these libraries. NumPy, you got an idea what NumPy does. What is Matplotlib? Matplotlib is basically a visualization library. So Matplotlib is usually used to visualize not just images. It is used to visualize any of your functions, like you map your functions, right? It can visualize your functions, scatter plots, histograms. I think there are a bunch of different things which you can visualize with MATLAB. Anything which is a result of a particular, if you have two values, right, you can always list as a line plot, bar graph, etc. All of these things are available for Matplot. Again, import matplotlib, from matplotlib, import pyplot as PLT. This alias PLT, don't ask me why. That's the standard which has been used for almost decades now. So better to use this alias because it's common. Anyone who's looking at your code will understand, and it's easier to write when you're writing longer codes. Next comes the skimage. Skimage is another library which will help you read your particular images. So Matplotlib usually helps in visualizing. Skimages helps in reading the file. So for example, this particular image, right, of IIT Hyderabad. So we had to, if we click the image using our phone or something, then from our local system or from your drive itself, if you want to load this particular image, you have a path, or since this is, I think, from a URL, you can either load the URL image using that io.imread. So skimage is basically used to load an image, and when you load that image, it automatically converts that particular image into a matrix. So that's why you see these what do you say, tick values, right? Like the values, access values, 0, 100, 200, 300, all these values. So this kind of gives you an idea of the shape of the image. So whenever you load any image using this library, it loads as a array or a two-dimensional, three-dimensional matrix. So if you want to print and see the values, if I say print, right, since it's a color image, you get the three-dimensional matrix. These are the different pixel values, 123, 126, etc. Bunch of values. So now you can do the type, like I said, data type, right? So this doesn't tell what data type of NumPy it is. It just says what is this array itself. It's a NumPy array. So that's why it says the type of this image is NumPy ND array. Is there other types? Yes, you will be seeing in the later part of the courses. There are something called as tensors from PyTorch, tensors from TensorFlow. Those are different from these NumPy ND arrays. So there are a bunch of different types which are different from the element data types. So the structure itself is different. Inside that, again, there'll be data types of each element. I hope that difference is clear. Then you have your shape. Again, since it's an array, that's what you get from the above cell. I think there's a question. Virendra, yeah, you can unmute and ask.
My question is, what is the difference between the NumPy array and a tensor?
Right. So tensors are usually, you see, ideally mathematically, tensor is nothing but any matrix which is, or sorry, any data array which is more than 3 dimensions or 2 dimensions for that reason. But tensors in PyTorch, right, you call it torch.tensors. Those are having a different types of functionalities, just like NumPy np.arrays have. They have their own set of functions that you can run on them. Torch.tensors will have their own set of functions, like how to calculate the gradients, or how to do a bunch of different other operations, which NumPy can't do on those particular tensors. So these are basically from different languages, so their types are different, you can say.
Okay.
Yeah, but mathematically a tensor is nothing but more than 2-3 dimensions.
Okay, so regarding RGB image, the one that we are seeing, it's like, is it a list of 3 two-dimensional arrays?
List of, can you repeat? List of what?
So we have, if you just go up a little bit,
Sure.
we see that there are so what is the shape and size of this? Can we have a look? So
Yeah,
what
so
does the
here
third
this,
channel represent basically?
yeah, this is the three things basically. 827 is the width, 1241 is the height, and
Okay.
3 is the number of channels. So if you want to plot each of the channel, this is what you see. This is the red, blue, green. So I was wrong. The first one is the height, width, and number of channels.
number of channels. So basically, there are three matrices of the shape 827 by 1241. Is it like that?
Yes, you can think of them to be 2D matrices, three of them, and you pile
Three
up
of them.
each one behind the other. That's how you get your red, green, blue.
So there is a third dimension, right?
Exactly, the depth dimension, you can visualize it. That is the third dimension where you stack all these 2D matrices.
So the in the third dimension, if you suppose look at it, the first one is the red one, right?
Right,
Then this is blue, and then that is gray.
green. Green.
So oh, sorry, green. Yeah. All right. Okay. 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 Thank you so much.
Sure. So yeah, so these are the individual channels of that particular image. You can also always import or show your image in a particular gray format. Gray is basically just one channel, grayscale, which is zero, which is black, which is anything between white and black. You don't see any color. You can also
So can we see the dimension of this gray? I mean, what is
Yeah,
how does it make it gray when there are three channels? What does it
yes.
do?
So it just the value basically it just picks any one of the channel and normalizes between 0 and 1.
Oh yeah. Yeah.
So the shape remains the same. It's just that the channel 3 is eliminated. It's just one, right? So you just have 827 to 124.
So there are three matrices of the shape 827 by 1241. When it makes it gray, which of these three it selects, or how does it do that?
Oh no. It doesn't select any of those. Here I the exact question, yeah, interesting question. So here what they do is I think they sum up all the values and then they normalize it between 0 and 1. That's how they create. Exact functionality of how they're creating, basically, if you see over here, CMap equals to gray. We'll have to look into how this CMap equals to gray converts the RGB into gray.
Okay, okay, okay.
Yeah, just look into this particular argument. I am sure CMap. I think they'll give you a process of how they convert. I'm 90%, 99% sure that's how they do it. I'll also just confirm once and let you know.
So
Let's
that
go.
they just take the average of three channels. Is it like that?
I
And then normalize.
I believe that's how they should be doing. I don't know because each library has their own implementation.
Yeah, yeah,
I,
fine. Yeah.
yeah, I'm also not very sure, but yeah, I'll also confirm that once. Yeah, good question.
Okay, okay.
I think Kiran, yeah, maybe you can. You're not audible, Kiran. Kiran, maybe you can type it out. I can't.
Sir, can you hear me now?
Yes, I can hear you now. Yeah.
So can you please show me the previous image?
This one.
Yeah. Sir, what is the plot CM reds R, sir? Reds underscore.
Right. So basically, it's the red channel. You're extracting the red channels. So you're extracting the red channels by saying 0, and you're telling the CMap that this is a red channel. So CMap is the functionality of this matplotlib, which it tells you what type of a channel you're giving as input. Either it's a single channel like red, blue, green, or it's a gray channel.
Okay, sir.
Yeah. So definitely read up on CMap. You can understand it better. Like what exactly does it do? Like the name says, it's a mapping basically to identify what channel are we using.
Okay, sir.
What color channel are we? Yeah. So once you convert to grayscale, also the size always remains the same. Only the height and width remains the same. The channel just goes away. It's just a single channel. So next, moving on, like we also said, image can be a function, like discussed in the lectures. So if you want to think about it, let's just take this image of a horse, which is basically a black and white image of this particular shape. I think it's 320 cross 40. Yeah, sorry, 328 comma 400. That is the shape of this image. Now, if you print just the values, right? Here, instead of storing it with a particular number, we're just storing it with true or false because it's a binary image, right? It's just 0 is like black, 1 is just white. So it's just a true or false, 0 to be true, 1 to be false. Yeah. Now, if you want to represent this as a function, you can just create a small function f of xy, which basically whatever point of x and y you're giving, it returns the pixel value of this image x and y. And that's what you form. This is the function of that particular image. So you can always represent images as a function like this. Just create a simple function f of x, and whenever you're giving a particular x and y location, right, in this particular grid, it will output a value. That output value will be seen on z axis. So you can assume this to be x and y, and the z axis is the height axis. So this is how you represent image as a function. Okay, and then moving on, you also have a bunch of different transformations that you can do. So what are the transformations? I mean, like the original image is shown on the leftmost side. You can either increase the intensity, like make it more bright, or you can flip the rows, is basically inverting the image upside down. You can either flip the columns like left to right. All of them here, the flipping columns, flipping rows. This is where your stride function comes into play. If you remember, I told you, right, in an array, if you just write this double colon minus one, it will just reverse the rows or reverse the columns. That is actually how here it is used. So those all functionalities are very helpful. I mean, here you can easily see, because it's image, it's not just for images, it is always helpful to handle any type of data when you want to reverse or do certain operations. So this is how we can do. These are just limitations, like the limited examples. There are a bunch of other transformations which you can do. Now let's go to the operations. Like we discussed, like sir discussed in the lectures, there are a bunch of different operations you can do: point operations, global operations, and local operations, right? So point operations is when your particular pixel value is affected by it. So for example, okay, you want to first reverse the contrast. You write a simple pixel function. The maximum pixel minus what the pixel value of that particular element plus the minimum. So this will basically reverse all the contrast. So this is how you see, previously which was black now becomes white, previously which was white now becomes black. So this is a simple pointwise operation which you did, where you took each pixel value, subtracted it with the maximum pixel value, which is 255, and added with the minimum value, and you're reversing the entire contrast. Now there's another operation called linear contrast stretching. So this is the original image, and now you want to linearly change the contrast. So what does it mean? I'll show you the example. So here, this is the function. You're basically taking it's kind of like normalization in a way, I would suggest, but you're also the contrast should be linearly increasing. It's not like there's a sharp difference in the contrast between the two images. I don't know if you can see through the in the particular image which I'm showing right now, but if once you get the notebook, right, you can clearly see the difference. The contrast will be more gradient linearly stretching in the right side than the left side. Left side is the original image. Once you get the Colab notebook, maybe you can see it much more clear. But these are just some examples. You can always do a bunch of different operations. Then local operations also. Here, like there was an operation, right, where you take a patch of images, you do average of those patch, and you keep on moving the kernel, right? Basically, you can keep on moving the kernel, which keeps on combining the average. So that is your local operation. So if you want to look at that, this is your original input image. Then you apply first the padding. Here the padding we do because you don't want to lose information of the edges. And yeah, then this is a small for loop you need to write. So basically you're going from the range, right? 0 to the shape, which is the height. Then j is going from 0 to the width or end of the width. And then you keep on moving that window particular patch, right? You keep on sliding it over your original image, and each particular patch you calculate the average, and you keep storing in this img moving average. So this is what you see. So it's a blurred picture. I think you already know from sir's lecture, but again, I'll ask this question: why did this get blurred? Like, why does average blur it out? I think it's pretty understandable. But any guesses?
VLL made low pass filter. Because of smoothing, I guess.
Yeah, because of smoothing. So because of smoothing, it's basically blurring out. if it's not smooth, you can see a contrast, like a sharp difference between these two pixel values. But since I've averaged it out, there's a bit of a smoothing and blurring effect. Okay, then you have your basic filters, cross correlation and convolution over the impulse signal. This was the example which sir used right in the lecture. What is the example? You have this input image. This is where we actually motivated how to why convolution is also needed. So it's the same example, but now in code format. So you have this basic input impulse, which is nothing but just one value. If you look at it, this is the matrix array representation of this image. You have all zeros except for this one value over here, 1. This is a 7x7 image. And now if you create a filter, what was the filter? This is the filter. So here you can see how we use linspace. If you remember, what is linspace? Sorry. What is a linspace? Linspace is basically creating elements in an array in a particular range, 0 to 1, and equally spaced. You want 9 elements which are equally spaced between 0 and 1. That is first what you create, and then you reshape it into a 3x3 matrix. So this is the output. So I hope you can see how NumPy is used in all these, right? So you're creating filters like these, and you can see much more applications as and when the course progresses. But yeah, these are some examples. So this is the filter which you create. Now, if you want to do, yeah, first let's do the cross correlation. It's the same formula which shows in the slides, but it's just written in terms of two for loops because, oh, 1 second. It's just written in terms of two for loops because you need to slide across the column and the rows. And but the formulation remains the same. You create a patch and then you do element wise multiplication and summation of this patch across the entire image. So this will be your output. Now, as you can know, the cross correlation inverts the filter, like it's not an identity. So that's why we do convolution. What do we do in convolution? You first rotate your, you use the rotate function, flip function, which you flip your kernel 2 times. So here you can either use your np.flip or you can use this double colon minus ones. If you remember, I was telling you when I was explaining the stride, right? You can use this double colon minus one to flip your kernels. That's what exactly which we do here. So you first flip your kernel and then you do the element wise addition and multiplication and addition. And that's how you get the output, which is the identity of your particular kernel. This is how convolution is done. I think, yeah. I'll just maybe stop over here because in the last few minutes I wanted to take up any questions. So I think the rest all is again separable convolutions. If you understood till now, it's all pretty straightforward. If you understood how matrices are represented as images and everything. So images is represented as matrix. Similarly, you have different kernels, Gaussian kernels and everything. Just go through it. Any questions, you can always take it in the next coming Tuesday. So just go through the Colab notebook. That's the one thing I would suggest. Read as much as you can on all the concepts which were mentioned. Any questions, anything, we can always discuss. And I'll also go through about the CMAP thing, how the grayscale. That's a very good question. I'll also go through that and I'll let you know in the next class. Okay, that's it from my side. Any questions and we can discuss right now. Yeah.
Where this collab will be shared actually?
Yeah, so I think usually what is the process is there's an Excel sheet where we upload all the, there's first a drive where we upload all the contents, presentations, Colab notebooks, and the drive link we keep it in an Excel sheet, and that Excel sheet will be shared with you. But I've been informed that it's not yet shared, so I'll make sure I'll call like the NPTEL office or contact them and I'll see why it is not being shared yet. So most likely it should be shared in the forum or it should be mentioned in the NPTEL website itself.
Okay. Okay, thank you. So basically we will go through this and if there is any question we can discuss in next class, right?
Yeah, sure, no problem.
Okay, thank you.
Okay, so Kiran, like I said, I'm also not aware of a study group officially. I don't think there's any official study group, but unofficially you guys can, like, people who are taking the course, maybe you can all form a group and discuss your doubts. Even if that's not clear, there's a forum. I don't know if you're aware of the forum. That's where people post the questions and their doubts and everything. You can ask in the forum also. If you want a study group, you can create your unofficially study groups also. But I don't think there is officially any study group. Long response time. I'll talk to the actual NPTEL TAs also, the other NPTEL TAs. Yeah, we'll try to resolve with the response time, sure.
Sir, one question is there. Sir, where should I get that PPT of the each and every lecture, sir? I mean, what sir have explained?
The professor's lectures.
Yes, sir.
Oh, the professor lecture is actually available on the website itself. So in the in your course, like NPTEL SWAYAM website, right? In the course on the left side, there'll be bunch of different toggle buttons. In that, if you click, you'll have week 1, week 2, and in week 1 you'll have all the lecture videos, and in the end of week 1 you'll see lecture slides. Similarly, for week 2 also you'll have lecture videos. End of it, you'll see lecture slides. So click on that, and you'll be directed to a drive link.
Sir, it's showing like download videos, text transcripts and books, not any kind of PPT stuff, sir.
No, I think someone has mentioned it in the group, in the chat actually right now. If you can just click on that, because I've actually checked it, so it is available.
Okay, okay.
Yeah.
Let me. It would be my fault. Okay.
Yeah.
I'll take it, sir. Yeah.
Sure, sure.
Thank you, sir.
Sure. Any other question? Anything? Okay, I think if there are no questions, let's end this session. Okay. Thank you all for joining.